Hi guys. Today we're going to learn about we're going to do a chapter 2 practice exam, and this is under college algebra. So this is what a typical chapter 2 practice exam for college algebra might look like. So let's begin. So let's start with number 1, and the direction says in exercise 1 through 3 use intercepts and symmetry to sketch the graph of the equation. So recall, so we have y equals 3 minus 5x. We can rewrite that as, I'll put it right here. We can rewrite that as, remember, negative 5x plus 3. Remember, this is the slope, or the y equals mx plus b, right? The m is the slope, so our slope is negative 5. So m is negative 5, and the y-intercept, y-intercept is 0, 3, right? Okay, so but the direction says we're not going to do the rise over run method. We're going to do this find the intercepts, find the intercepts and symmetry. So we already have one intercept, and that's called our y-intercept. So right, so we have a y-intercept automatically at 0, 3. So we could plot that. So let's plot it on this graph. 0, 3. So here's my x and here's my y. So 0, 3 would be right here. Okay. Now let's find our other intercept. So what would be our other intercept? It would be our x-intercept. And do you remember the rule of finding the x-intercept? You simply replace y with 0 and solve for x. So let's set up the equation. So we have a y equals 3 minus 5x. So that's going to be 0 equals 3 minus 5x. And then let's solve for x. So what I'm going to do is subtract 3 from both sides. So I get negative 3 equals negative 5x. And then I'm going to divide everything by negative 5. So x is positive 3/5, right? Which is about 0.6. So our x-intercept in coordinate form would be 0.6, 0. So let's plot that. So right here, this is 1, so 0.6 should be right about here. Okay, so we found our two intercepts, the x-intercept and the y-intercept, and then you just connect the dots. That was not really straight, but try to make it really straight. And then, yeah, that's it. And I don't see any symmetry. Yeah, I don't see any. Since it's a linear graph, I don't really see any symmetry. Okay. Yeah, so that's one way of graphing this linear function. Let's move on to question 2. So same directions, we got to find intercepts and any kind of symmetry. So we have y equals 4 minus absolute value of x. So this is no longer a linear graph. I'll just write whatever. When you ever graph any kind of equation, any kind of graphs, just the simplest way is just to list everything you know about the graph. So what do I know about this graph? Y equals 4 minus absolute value of x. So we know it's automatically an absolute value graph, right? And if you recall, absolute value graphs have that V shape. So it kind of looks like this. So this is y equals absolute value of x. Okay, what else do we know? Do you see this negative right here? That means we have a reflection on x-axis. Reflection on x-axis. Okay, good. And then what about this 4? That 4, that's a positive 4. Just also, you can also rewrite this as y equals, if it makes it easier, you can rewrite this as y equals negative absolute value of x plus 4. So this 4 is positive. So what does that 4 mean? It means we have a reflection of 4. We have a vertical shift of 4 units upwards. So we have a vertical shift of 4 units upwards. Okay, so let's see here. Can we find any intercepts? I think we can. We can find the y-intercept. Remember, to find the y-intercept, you simply plug in 0 for x and solve for y. So that's going to be really simple. That's going to be 4 minus absolute value 0, which is just 4. So our y-intercept is 0, 4. Okay, so this negative, so when we graph it, let's plot the 0, 4. Here's 1, 2, 3, 4. Here's 0, 4. Now this negative means there is a reflection on the x-axis, so it's going to hit downwards. It's not going to go upwards. So it's going to go downwards, and then it's going to look something like this. There is an invisible 1, or you could think of this as sometimes people think of like this as an invisible 1, and then could be your slope. So you start the y-intercept, and then what you can do, since it's going downwards, you could go down 1, right 1, down 1, right 1. So it's gonna, down 1, right 1, down 1, right 1. So you get that V shape. Okay. Or you could just plug in points. What you can do is plug in points. So if you plug in x for 1, so 1 would be 4 minus absolute value of 1. And that was going to be absolute value 1. So that's 4 minus 1, absolute value 1, but there's a minus, so it's going to be 4 minus 1. So that's going to be 3. So this coordinate would be 1, 3. Whoops. So I kind of made a mistake right here. So let me erase this. So we'll plug in the point 1, 3. So it's going to be 1, 3. So it's 1, 2, 3. No, actually, I did it right. 1, 3. Yeah, so what you could do is go from the y-intercept and go down 1, 1, down 1, right 1, down 1, right 1. If you don't want to plug in points, down 1, right 1. So yeah, down 1, right 1. So it's going to look like this. Over here, we're going to go down 1, right 1. I mean, left 1, down. Left 1, down 1, left 1, down 1. Just like the last one. And then this should make this beautiful V shape. Okay. So that was question 2. Let's move on to question 3. So we have a y equals x squared minus 1. So we got to find any kind of x intercepts and any kind of symmetry. So this x squared, I automatically think this automatically becomes a parabola. Okay, so let's list everything we know. So we know it's a parabola, or yeah, it's definitely a parabola because it's x squared. Parabola. What else do we know? Let's see. This -1, what does that mean? It means there's a downward shift, a 1 unit downwards, right? There's a vertical shift, or we call it a downward shift, same thing. So it's a downward shift. Oops. Downward shift of 1 unit down, of 1 unit downward. Okay. Let's see here. We could actually find, let's find our intercept. So let's find our y-intercept. So to find the y-intercept, you plug in 0 for x, so it's going to be y equals 0 squared minus 1. So our y-intercept is pretty simple. It's pretty much our downward shift. So y-intercept is 0, -1. Okay, what else do we know? Let's find our x-intercept. Now, to find the x-intercept, plug in 0 for y, and then solve for x. So it's going to be 0 equals x squared minus 1. And then before you add 1 and then do that square radical both sides, there's this, you could do completing the square, because this is a completing the square, perfect square. So this is good. When you factor x squared minus 1, it's a perfect square. So it's going to be x plus 1, x minus 1. Or what you can do is just add 1 to both sides and then square root both sides. You still get the answer. So we get two x values, two x-intercepts. We get x equals 1 and -1. So our x-intercept is 1, 0, and then our other one is -1, 0. Good. So we know it's a parabola. It has downward shift. It has a y-intercept of 0, -1, and it has a x-intercept of 1, 0, and -1. So let's apply, and we know this is going to move upward. It's concave up. Remember, because there's no negative right here. So first what I'm going to do, I'll plot the y-intercept. So here's -1, 0, -1. Now let's plot my x-intercept. 1 is 1 here. And the other one's right here. And then just make the U shape, right? Hopefully. There, good, did it. So here's your parabola. And then what else? Yep, that's it. There's no reflection. Wait, there is. I would say reflection on x-axis. Because if you fold the paper in half, yeah, I would say there's definitely a reflection on x-axis. Because if you fold the paper in half, you get the same image. So that was 3. Let's do 4. Okay, so we're going to do completely something different. We're not graph. This one it says we're going to find an equation. So in exercise 4 through 7, it says find an equation of the line passing through the given points: 2, -3, and -4, 9. So for this one, we're going to need some formulas. So my first formula I'm going to use is the slope-intercept form. So if you recall, the slope-intercept form is y equals mx plus b. So this is called the slope-intercept form. Okay. Now we got to use we got to find two things: the slope and the b, right? So let's find our m. So they don't give it to you, so you're going to find it. So it's really simple. You just use how to find m is you take the change of y, so y2 minus y1, over change of x, so it's x2 minus x1. So how you label this is just x1, y1, x2, y2. Okay. Now if we know our x1s and y1s and x2s and y2s, let's just plug it in. So y2 is 9 minus y1, which is minus a minus 3, so there's two minuses, over x2, which is negative 4, minus x1, which is 2, minus 2. So this is going to be 2 negatives becomes a positive, right? So what's 9 plus 3? 12. And then what's negative 4 minus 2? Negative 6. So that is negative 2. We just found our m. Now, our next step is we got to find our b, or our y-intercept. So what you do is you pick a point, and then, yeah, you pick a point. So it doesn't matter which point. I'll just circle this point. I would always circle it just to make sure you won't get confused. So now we're going to put it in this form. So to y equals mx plus b. So we already know our slope, right? It's negative 2. So let's replace m with negative 2. Times it by x. So what is our x value? In our coordinate, it would be 2. And we don't know our b, so that's what we really want to find. So we're going to replace that just with plus b. So this is going to be y equals negative 2 times 2 is negative 4 plus b. Whoops. And then what do I replace with y? Negative 3. So replace y with negative 3, so it's going to be negative 3 equals negative 4 plus b. And then you add 4 to both sides. So b equals 4 minus 3 is 1. Good. So we found everything. We found our b, we found our m, and then we'll just have to put it in slope-intercept form. So our slope-intercept form is going to be y equals, our m is negative 2x, negative 2 times it by x, which is just x, and then plus b, which is 1. Don't replace x with 2, because you won't have a slope. It would be negative 2 times 2 would be 4. No, we have to put in x here. And then our b is, what is our b? 1. So it's going to be plus 1. So here's your final answer. Y equals negative 2x plus 1. Simple, yeah? Okay, let's do 5, number 5. Okay, so 5 says, find an equation of a line that passes through the point 3, 8, and A is parallel to, and B perpendicular to the line negative 4x plus 7y equals negative 5. Okay, so we need to find two things. We got to find an equation that's parallel and one that is perpendicular. So this negative 4x, let me write this, put it ready, negative 4x plus 7y equals negative 5 is what's called standard form, right? If you recall standard form, you should know all of the formulas for linear graphs. This is still technically linear graph. In standard form, this is ax plus by equals c. So now we got to put it in slope-intercept form, because that's how, yeah, now we got to put it in slope-intercept form. So we got to put it in y equals mx plus b. So what we have to do is get y by itself, right? That's what we have to do. We have to get y by itself. So what I'm going to do is, let me write it right here. Got to get y by itself. So what I'm going to do is add 4x to both sides. Okay. And then this is going to be 7y equals 4x minus 5. And then to get y by itself, yeah, divide everything by 7. So y equals 4 7x minus 5/7, right? Okay, now let's do part A. It says we need to find an equation that's parallel. So if you recall, two lines are parallel. is when their slope are the same. So m1 must be equal to m2. So let's look at this equation. What is my slope, or my m1? Our m1, or slope of this equation, is just 4/7, right? So our m2 must be 4/7 as well, but the only difference is our b is going to be a little bit different. So let's put it, so it's going to be y equals 4/7x plus b. Now, how to find b? Remember, they give us a point, 3, 8, right? The 3 is our x, and the 8 is our y. So we're going to plug it in to this equation. So y is 8. And this is going to be 4/7 times it by x, which is 3, plus b. So this is going to be what? 4 times 3 is 12 over 7 plus b equals 8. My goal is to solve for b, but I have a fraction, so I want to get rid of this 7. So what I can do is multiply everything by 7 to make it easier. So 7 times 8 is, let me put it right here. 7 times 8 is 56. I'm putting it right here. And then the 7 times, so I'm multiplying 7 to everything. This, and this. So 12, 7 times by 7, the 7 cancels. So you're just left with 12 plus 7 times b, which is just 7b. Okay. Now this might be simpler, so subtract the 12 from both sides. So 56 minus 12 is 44 equals 7b, and then you divide everything by 7. And you get b equals 40, what is it? 44 over 7. And that cannot be reduced, right? Okay, so now let's put it in slope-intercept form. So our final equation for the parallel line is y equals 4/7, because our slope is still 4/7, because m2 has to be same with m1. So it's 4/7 x plus the b, which is 44/7. 44 over 7. So this is answer for part A. So this is part A answer. Now let's do part B. So something that's a line that are perpendicular, the rule says that in order for something to be perpendicular, and perpendicular. Let's see. I guess I have to do this. I didn't do the perpendicular, so I'm going to do this with you guys. So in order to be something to be perpendicular, m1 times m2 should be, the outcome should be -1. So it's m2 should be the negative reciprocal of m1. So m1 is 4/7. So the reciprocal. So let's find m2. So m2 must be the negative reciprocal of m1. So m1, the reciprocal of 4/7 is 7/4. And then it says negative reciprocal, so you have to add a negative. And how you can check it is you do m1 times m2, the outcome should be -1. So if you do 4/7 times -7/4, if you multiply that out, you're going to get an outcome of -1. So that's how we know m2 is -7/4. Just remember, it's the negative reciprocal of m1. So we found m2. Now let's find our b. So y equals -7/4 x plus b. We're going to still use the same point because we got to have a different b. So this is going to be y equals 8, -7/4 times it by x, which is 3, plus b. So this is going to be -7/4 times it by 3 is -21/4. 8 plus b. I don't like fractions, so I got to get rid of this. So I'm going to multiply this bracket means we have to multiply everything by 4. So 8 times 4 is 32. And 4 times -21/4, the 4 cancels, so you're left with -21. plus 4 times b, which is 4b. So you're going to add 21 to both sides, add 21 to both sides, and let me put this in the calculator because I didn't do it. So 32 plus 21 is 53. I'll put it right here. So this cancels. 53 equals, now you're left with 4b on the right side. And then divide by 4, divided by 4. So b equals 53/4, right? And then, let's see, can 53 be divided by 2? It can't, so this is the most simplified. So our final equation for, so the question answer for part B is y equals, the slope is negative, m2 is negative 7/4 x plus b, which is 53/4. So this is your answer for part B. Okay. Okay, so now let's do something completely different. And I don't think this is too hard. It says evaluate. So we're given a function f of x equals square root of x plus 9 over x squared minus 81, and we got to find three things: f of 7, f of negative 5, and f of x minus 9. Yeah, this isn't too hard. You just plug it in, and then your outcome. So let's do part A. So let's find f of 7. So wherever you see an x, you just plug in 7, right? That's it. So it's going to be square root 7 plus 9 over 7 squared minus 81, right? This is going to be square root of 16 over 49 minus 81. This is going to be what? Square root of 16 is 4, and then 49 minus 81 is negative 32. And then this reduces by 4, so your final answer should be negative 1 over 8. Okay, there you go. That's answer for part A. Let's do part B. I'll put it right here. So let's find f of negative 5. So where have you seen x, plug in negative 5, so it's going to be radical negative 5 plus 9. Negative 5 squared minus 81. So the 9 plus negative 5 is radical 4. Negative 5 squared minus 81, so negative 5 squared is negative 25, minus 25, minus 81. So this becomes square root of 4 is 2, and then bottom, the denominator becomes negative 106. And then you divide, this can be reduced by 2. So this becomes negative 1 over 53. Now let's do C. See if I have space. Where should I put it? I'll put it right here because I don't have much space. So C is, I'm going to put it right here. So we got to define x of minus 9. So we're going to do f of x minus 9. So it's going to be radical. So wherever you see an x, you're going to put x minus 9. So you kind of have to be careful. So this is going to be radical x minus 9 plus 9 all over x squared. So it's going to be x minus 9 squared minus 9. Let's simplify. The 9's cancels on the top, so you're just left with x. So this is just going to be square root of x. And then x minus 9, you got to FOIL it out. And then if you FOIL x minus 9 square, you're going to get x squared minus 18x plus 81. And then you have a minus 9, so bring down that minus 9. So if you simplify this, it's going to be radical x over x squared. Okay, so let's simplify. X squared minus 18x plus 81 minus 9. This becomes x squared minus 18x plus 72, right? Now, this x squared minus 18x plus 72, it could be factored, right? This is x, and then two numbers when multiplied gives you positive 72, and when added gives you negative 18. That is going to be minus 9 and minus 8. So your final answer is x minus 9, parentheses, x minus 8. Nothing can cancel, so you're just going to leave it like this. Simple, right? So that was 6. Let's do 7. Just go back a little bit. Okay, so number 7 says determine the domain of f of x equals square root of 100 minus x squared. So we got to find the domain of this graph, of this radical graph. So in order to find, sometimes graphing it makes it easier to find the domain because you'll know overall the domain is pretty much the x values. So yeah, how I would do this is I would graph this one. So the graph of y equals square root of 100 minus x squared, it's going to look something like, it's a half a circle, if you recall. You could put it in a graphing calculator, or you could just, if you didn't know how this graph would look like, you could actually test points. So if you don't know how, like I know on top of my head, this is definitely a half a circle. But if you didn't know that on top of your head, what you could do is test points. And then what I would do is pick some positive x values and some positive x values, and then definitely 0, and then some negative. So I'm going to use my first x value, I'm going to use 0. So when you plug in 0 into the function, it's going to be our y values. So our y value is going to be y equals radical 100 minus 0 square. That's just radical 100, right? And we know that the radical 100 is 10. But remember, when you take the radical, you get two answers, 10 and negative 10. So if you plug in 0, you get 10, and then another y value is negative 10. What if you plug in 10 for the value, x value? Your y value is going to be 0, because 100 minus 100, because 10 squared is 100, you get 0, right? And then what if you plug in negative 10? Well, I think this is the reason why you're going to get 10 and 0, negative 10. When you plug in negative 10, you're going to get 0. So really, you could have just plugged in 0 and you would automatically get a graph of this. So when you graph it, it's going to look something like this. So my highest, actually you're just going to get, don't include the negative 10. Just try positive values for the, when you plug in 0, yeah, don't include the negative 10, because this is definitely a half a circle, right? Well, yeah. So this is going to be, our x values are going to be 10 and negative 10. And then over here, our highest y value is 10. So it's going to look like half a circle, and it's going to look something like this. Okay, so what is my domain? Remember, domain is the x value. So what is 10? So our domain is always on the x-axis. So what is my smallest x value? Negative 10. And then what is my highest x value? 10. Now, our domain, so how do you write the domain is, am I going to use I'm going to put it in notation formation. So it's going to be bracket -10, comma 10. The reason why I'm not going to use parentheses, is because bracket means that value is included. So when you plug in -10, you get a y value 0. So that means it is included. It's like a dark circle. So yeah, that's why I'm going to use bracket from -10 to +10. Okay, that was 7. So yeah, when you find the domain, sometimes it's just easier. Just first, what I would do is, if you know how to graph it, go ahead and graph it, because that would make it so much easier. Okay, 8 is kind of long. Yeah. Okay, so we get two functions. So we have on 8, we have two functions. F of x equals 3x squared minus 7, and then g of x equals -x squared minus 4x plus 5. We got to find all of these. F of x, a, b, c, d, e, f, g. We got to find f plus gx, f minus gx, f of g times x, f divided by g times by x, and then fog and goff. So let's do part A. So I'm going to put it right here. So when you FOIL out this x, right, you're going to get f of x plus g of x, right? When you FOIL this out, this is what you get, f of x plus g. Now, this is pretty simple. So we know that, we already know our function f of x is 3x squared minus 7, so it's going to be 3x squared minus 7, and then plus g of x. So g of x is this whole thing. If you want, you could use parentheses, so you won't get confused. Okay, now it's all about combining like terms. So over here we have a square. Let's look at our squares. So we have a 3x squared, and then we have a -x squared. So that would be positive 2x squared, right? And then over here we have, let's focus on our x's. We only have one x, which is that -4x. So it's going to be -4x. And then over here, let's look at our whole numbers. -7 and +5, that's going to be -2. We just found the answer for A. Now let's do part B. So when you FOIL this out, the x, you're going to get f of x minus g of x, right? This is pretty simple. So we know that what our f of x value is just 3x squared minus 7. Now we have to do a minus g of x. So it's going to be minus, and then what I'm going to do is put parentheses, because you're going to distribute this negative. So this is going to be -x squared minus 4x plus 5. So when you distribute this negative, this is going to be positive x squared. This is going to be positive 4x. And then this is going to be -5. And then just bring the 3x squared minus 7 down. Okay, now you can just combine like terms. Let's see, focus on our x squares. We have a 3x squared here and an x squared here. That's going to be 4x squared. And then let's look at our x's. We have only one x, which is the 4x, so it's plus 4x. And over here we have, let's look at the whole numbers, -7 and -5, so that's -12. So this is the answer for part B. C is, let's do C. I have to put it over here. So I don't think I'll have space. So C is f of g times by x. So when you FOIL this out, it's going to be f of x times g of x. So we know that f of x is 3x squared minus 7. And then we're going to times that by g of x, and g of x is this whole thing. Now, I know you know how to FOIL, so what I'm going to do is just, you FOIL this, 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 and then the -7 with this, this, this. So I'm just going to show you the work, because you should know how to FOIL things. So this should be, when you FOIL this out, you get -3x fourth minus 12x cubed plus 15x squared plus 7x squared plus 28x minus 35. Okay, now when you FOIL it, this is what you get, and then I guess you combine, the last step is combine like terms. So when you combine like terms, this is what you're going to get. -3x fourth minus 12x cubed plus 22x squared plus 28x, and then minus 35. So this is the answer for part C. Pretty simple, you just FOIL it out and combine like terms. I'm going to do part D right here because I don't have space. So part D, I think you're just dividing it. So this is part D, f of g times by x. So when you FOIL this out, this is what you're going to get. F of x divided by g of x. So you're just dividing f of x. So it's pretty much this. F of x is 3x squared minus 7, and then g of x is -x squared minus 4x plus 5. What you can do is you can actually just leave it like this, 3x squared. Yeah, you could just leave it like this because it can't be simplified anymore. Okay, so now let's do the last one, or let's do the fog. So this is not multiplication, this is more like, this is what's called decomposition. So this is E. So this is going to be parentheses f of g. This is not multiplication, this is f of g times by x. And you can think of this as f of g of x. So what you're doing is you're putting the function g of x inside the function of f. So you recall, let's review a few things. So I'll show you what I'm doing. So you're plugging, here's g of x, you're putting this inside the function of f. So wherever you see an x, you're going to put this whole thing, -x squared minus 4x plus 5. So let's do that one. So let's do that one. So when you put in the function g inside the f, this is what you're going to get. Negative 3x squared minus 7 squared minus 4, 3x squared minus 7 plus 5. Okay, so this is going to take some this is where your foiling rules will come in handy. So when you square this, don't distribute the negative first, but just FOIL this out. This is what you're going to get. You're going to get 9x fourth minus 42. Whoops, I think I did the wrong one. Yeah, I was sorry. I did the wrong one. So let me erase this. Yeah, I think I'm doing, that was F. Okay, so when you put this is what you're going to get. 3. It's going to be negative 3. Whoops, no, actually it's going to be 3 times negative x squared minus 4x plus 5 square minus 7. Before I FOIL this out, I want to make it more simpler. I can do is factor out a negative from here. So when you factor out a negative, this is going to be negative 3 x squared plus 4x minus 5 squared minus 7. That would make it much easier when you FOIL it out. So now you could FOIL this out. So when you FOIL this out, you're going to get x fourth plus 8x cubed plus 6x squared minus 40x plus 25 parentheses, and then remember this negative 3 doesn't go away, and then also the negative 7 doesn't go away. So when you FOIL out this negative, this is going to be negative 3x to the fourth minus 24x cubed minus 18x squared plus 120x minus 75, and then don't forget about this negative 7. Now the last step is collect like terms. So when you collect like terms, this is your final answer should be this. Negative 3x to the fourth minus 24x cubed minus 18x squared plus 120x minus 82. 120x. So here's your final answer. Okay, now let's do the last one, F. Now it's like going backwards. Now it's Goff. So this is what F says. You got to find Goff. Now it's not the same thing as this one. So Goff is equivalent to saying G of f of x. So remember, now we're kind of going backwards. Remember we were putting g inside of f of x. Now what you're going to do is you're going to put f, the function f of x, inside the function of g. So it's backwards. So when you do that, this is what you're going to get. Negative 3. It's going to be negative 3x squared minus 7 squared minus 4 3x squared minus 7, and then plus 5. So when you FOIL this out, 3x squared minus 7, this is what you're going to get. 9x to the fourth minus 42x squared plus 49. Yeah, if you don't, there's a special rules for this. It's under my channel, under one of my videos. So if you forgot how to do FOILing special rules, check that out. So okay, now this is going to be, when you FOIL this 4, this is going to be negative 12x squared plus 28x plus 5. Okay, now what I'm going to do is FOIL out this negative. So this is going to be negative 9x to the fourth plus 42x squared minus 49 minus 12x squared plus 28 plus 5. This is going to be minus 9x to the fourth plus 30x squared minus 16. And that's your final answer. Okay. Okay, that was a lot of work, so now let's go do something completely different. Let's do number 9. It says, so we're going to do something completely different. It says, determine whether or not the function has an inverse, and if so, find the inverse of the function. So remember, if you recall inverses, you can determine if it has an inverse if you do the there's a rule. So let's see here. The rule is it has to satisfy these two rules in order to figure out if it has an inverse. Or what you can do is okay, so here's how you do it mathematically. This is how you do it. This is how you tell if it's mathematically you have an inverse. The rule is it's going to be f of inverse of x equals x. So what you're saying is if you take the inverse, if you're put the inverse, this is a composition, you're putting the inverse of into the f, and then the outcome should equal x. And it should also, so this is this is kind of like the composition, just like the last one we did. So if you put the function f of x inside the inverse of f, inside the function inverse, f of inverse, the outcome should also be x. So let's see here. So let's do this part. So we got to find f of inverse, right? So how I would do is find f of inverse. So how do you remember how to find the f of inverse? So first step is you replace f of x with y. Next step, switch the x and y's. And then solve for y. So what I would do is raise everything to the 1/3 power. What? Actually, before I do that, before I raise everything, I'm going to subtract that 8 to both sides. So you're going to get x minus 8 equals y cubed. And then you raise everything to the 1/3 to get rid of this 3. So this is going to be x minus 8, raise it to the 1/3 equals y. And then the last step is replace y with f of inverse. So f of inverse of x is this whole thing. X minus 8, raise it to the 1/3 power. So we've just found our f of inverse. So let's put it in this equation. So you're going to put f of inverse, which is x minus 8, raise it to the 1/3, into the function x cubed. So wherever you see an x, put this in. So it's going to be x minus 8 to the 1/3, raise it, remember we have to raise it to the 3rd power, plus 8. Now, remember the rule for whenever you're raising something, what do you do with the power? You're actually multiplying, right? So when you raise something, you just multiply the exponent. So 1, what is 1/3 times 3? It's just 1, right? They just cancel. So you're left with x minus 8, raise it to the 1, or you can just leave it at x minus 8. And then don't forget the 8. And when you simplify this, the 8 cancels, so you're just left with x. Okay? So it satisfies this part. Now we got to, if it satisfies this part, we have to find the inverse. Okay, so now let's do part B. So f of inverse times f of x equals x. So we know our f of x, so you're going to put this f of x into the f of inverse. So this is kind of tricky. So put this inside of this, if that makes sense. So wherever you see an x, you're going to put x cubed plus 8. So wherever you see an x, you're going to replace that x with x cubed plus 8, and then it's minus 8, x cubed plus 8, x cubed plus 8, and then there's a minus 8. Now this, and then remember, it's raising it to the 1/3 power. So this is kind of weird. Before you raise anything, what happens to the 8 cancels. So you're left with x cubed, raise it to the 1/3 power. And do you remember when you're raising something to the power, what do you do to the power? You multiply it. So 3 times 1/3, what do you get? Just 1, or x to the 1. And your outcome is x, so it satisfies this part. So yes, we just determined it has an inverse because it satisfies this part. And this is how you do it mathematically. If you didn't want to do it mathematically, what you can do is graph x cubed plus 8, and then graph x cubed plus 8, and then do not a vertical, but a horizontal line test. So if it passes the horizontal line test, so if it hits it just once, only once, then yes. If it hits it twice, then no, it doesn't have an inverse. Let me just, I think I should graph it just to make sure you understand this a little bit. Just let me graph these two functions. So let's graph x cubed plus 8. Let me graph that one. So remember, let's graph x cubed plus 8, because I think that was our original graph, right? So x cubed, wait, so let's pretend 8's right here. So it would look something like this. So this is y equals x cubed plus 8. Now let's graph the inverse of x. So the inverse is x minus 8 raised to the 1/3 power. So it would look, if you put the inverse, it would look something like this. Call this f of inverse x minus 8 raised to the 1/3 power. Okay, so here's a little, okay, so they didn't ask you for the domain, but I want to make sure you understand that remember, the domain of f, or y, because f is the same thing as y, must be equal to the range of f of inverse. Must be equal to the range of f of inverse. And the range of f, here's f, and the range of f must be equal to the domain of f the range of f must be equal to the domain of f of inverse. Okay, so if you were, let's look at the range of f of inverse. The range of this graph right here, what's my range of this? So the range of f of inverse is what? The range is the y value, so this keeps going up, up, up. This keeps going down, 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 but so we could call that as all real numbers. So it's negative infinity to positive infinity, right? The domain of f, let's see, here's f or y. What is the domain of this graph? This, remember, the domain is the x value, so this keeps going down, down, down. This keeps going up, up, up. So the domain of that is also all real numbers. Let's look at the range of f. The range of f is, here's f. The range of this graph is also all real numbers. And then the domain of f of inverse here's f of inverse. So what is the domain of this? It's also all real numbers. So the rule says the domain of f must be equal to the range of f of inverse. So let's see. Here's the domain of f. Does this equal to the range of f of inverse? So the range of f of inverse. Here's the range of f of inverse. They are exactly the same. So this rule works. This statement is true. And then they said that the range of f, so here's the range of f, negative infinity to all real, negative infinity to positive infinity, must be equal to the domain of f of inverse. So this is equal to this. So that satisfies this one. So yeah, remember this rule, because sometimes they will ask you the domain, find the range of the f of inverse. So if you have this rule, if you know this rule well, you won't get your domain and range wrong. That was 9. Okay, we're almost done. Okay, so number 10 says determine whether the function has an inverse function. So remember, you have to do a vertical line test. That's all you have to do. You don't have to do it mathematically. That the one I just showed you on top, that's how I showed you mathematically. But now graphically, there's an easier way. You have to do the vertical line test. I mean, not vertical, horizontal. I always get that confused. Horizontal, vertical, horizontal line test. So remember horizontal. So you just put a line through this, and if it hits it more than once, then no, it's not an inverse. If it only hits it once, then yes, it has an inverse. So this right here only hits it once, so yes, it has an inverse, because it has an inverse since it passes the vertical line test. Horizontal, since it passes horizontal line test. Okay. So yes, this one is a big yes. Let's see if this one, part B. So this is like an upside parabola. So let me do a horizontal line test. It hits here once, and then it hits here another twice. So no, it fails. So this is a big no. I say fails horizontal line test. That was it. Now, let's see. Let's do 11. how much problem? I think we stopped at. Okay, we're almost done. Okay, so number 11 says determine whether the equation represents y as a function of x. So this really, so the question says determine whether the equation represents y as a function of x. So to figure out if y represents a function of x is, remember this rule. You can only have one y value. If you remember this rule, you'll understand. You can only have only one y value, or one input, or one output, right? So let's see here. I'm looking, I know that this is automatically a big no because whoops, this y4. You're going to get 4 answers because of this radical force. So this is, I know that automatically this is going to be no because when you solve for y, so if you did solve for y, we're going to get negative y to the 4th, negative 16x, and then you divide this by negative 1. You get y to the 4th equals 16x. And if you raise this everything to the 1/4 power, you're going to get radical for 16x. You're automatically going to get more than one answer, right? So this is your output. You're going to get more than one output, right? You're going to get a positive, you're going to get a negative. So no, this is definitely, that's how you know it's not a represent, it doesn't represent y as a function of x. So you can only have one output. Almost done. In exercise 12 through 14, find the zeros of the function. So this is they give us this quadratic. It has 3 terms, and we says find the zeros of the function. When they say find the zeros, they're literally saying find the x values or the x intercepts. So what you have to do is when you're going to have to factor. So we have 3x squared minus 16x plus 21. You automatically can't do simple factoring, right? Well, before you factor, ask yourself, can you take anything out? You can't take anything out. You can't take 3 out of 16. So yeah, this is prime as can be. So now what you're going to do, you can't do, and then you have to ask yourself, can you do simple factoring? You can't do simple factoring because there's a 3 in front of here. So if you recall, you're going to have to do, whenever you have a non-1 in front of the x square, you have what's called bottoms-up factoring. And if that doesn't work, you're going to have to use the quadratic formula. So let's see if this works. So how you do bottoms-up factoring is first ignore the 3 for right now, so this is going to be x squared minus 16x. Then you multiply 3 and 21. So when you multiply 3 and 21, you're going to get positive 63. And then you set this to 0 and then factor this out even more. Now this is what's called simple factoring because this only has an invisible 1. So let's factor out this. So we need 2 numbers when multiplied gives you positive 63 and when you add gives you negative 16. So let me try negative 9 and negative 9 times negative 7. Let's see if that works. So negative 9 times negative 7 is positive 63. So it satisfies this one. And then when you add those 2 numbers, negative 9 plus negative 7, what do you get? Negative 16. So it satisfies this part. So we're going to use negative 9 and then negative 7. It doesn't matter where you put you could put the negative 7 here or the negative 9 here. It doesn't matter. Then go back to your 3, right? Remember, the 3 hasn't really gone away. So what you're going to do is divide 3 over the -9 and over the -7. The -9 divided by 3 simplifies as x minus 3, right? The x minus 7, this can't be reduced, the -7/3. This is what we do the bottoms up factoring. So what you're going to do is bring the 3 in front of the x. So this is going to be 3x, and then ignore the 3, so you're just left with -7 equals 0. And then the last step is, remember, we got to find the x values. So we got to solve for x. So we have 2 answers. What you can do is, sometimes people can see it. If you don't, what you can do is break it into 2 parts, into equations. X minus 3 equals 0, and then 3x minus 7 equals 0. And then you solve for x. You add 3, you get x equals 3. And then over here, you can add 7, you get 3x equals 7. And then you divide it by 3. So your 2 x values is 3 and 7/3. If you want it in coordinate form, you can rewrite that as 3, 0, and then 7/3, 0. Either way is correct. Okay. So that's how you find the zeros for this polynomial. Let's do 13. So we have 5x squared plus 4x minus 1. We're going to do exactly like 12. 12. We can't do simple. We're going to do bottoms up factoring because of this 5, right? It does not have a 1. There's a 5. So yeah, we're going to use bottoms up factoring. So what you're going to do is ignore the 5. So this is going to be x squared plus 4x. And then what's 5 times -1? -5. And then set that to 0. And from here, you could do simple factoring, right? This is always going to be an x and x. So you need 2 numbers. When multiplied gives you -5. When added gives you +4. I'm going to use +1 and +5 and -1, right? Because 5 and -1 gives me -5. So this satisfies that one. And when you add 5 plus -1, you get 4. So yes. Then remember, go back to the 5. So you're going to divide 5 over here, 5 over 5, and then over the -1. So 5 over 5 is simplifies as x1, x plus 1. Now this one doesn't reduce, so you're going to do the bottoms up. You're going to bring the 5 in front of the x. So that's going to be 5x, and then then you're left with the numerator. So that's just -1 equals 0. So now the next step is actually solving for x. So you could break it into 2 parts, 2 equations. And then you solve for x. X equals -1. And over here, you're going to add 1, add 1. You're going to get 5x equals 1 divided by 5. So your 2 x values are x equals -1 and then x equals +1/5. And if you want it in coordinate form, it would be -1, 0, and then 1/5, 0. Okay. Either way is correct. Okay, number 14. Okay, we got to find the zeros for this polynomial. Now, we're not going to use bottoms up factoring. You know why? Because we don't have 3 terms. We have exactly 4 terms. 1, 2, 3, 4. So when you have 4 terms, there's a special rule for 4 terms. You can try what's called grouping by factoring. Pretty simple. So what you do is, you can only do it grouping by factoring if you have 4 terms. So we have 1, 2, 3, 4, total 4. What you do is you break it into 2 parts. So I'm going to break it into this part, and then I'm going to break it into this part. So let's focus on the x cubed minus x squared. Can we factor anything out from the x cubed minus x squared? We can. We can factor out an x squared. So this is going to be x squared times x, and then this is going to be minus 1, right? Now let's focus on the negative 25x and the positive 25. Is there anything you can take out? Anything. We can. And then what can I take out? Can I take out a positive 25 or a negative 25? So this is the part where you have to kind of manipulate it. The reason why I'm not going to take out a positive 25 is because you're not going to get a factor of x minus 1. You kind of have to manipulate it to make it look like one of these factors. So that's why I'm going to take out a negative 25. Because when you FOIL this out, you're going to have an x here and then a minus 1. Right? It wouldn't work if I factored out 25. It would be x plus 1. And we want this to look the same as this. So that's why we can't take a positive 25. Okay, so I purposely made it look like this because I want this x minus 1 to be the same as x minus 1 here. Because when we write the factor form, we only have to write it once. And then you look at the term leftover, so we're left with x squared and minus 25. So that factor is going to be x squared minus 25 times it by x1. So whatever that repeats more than once, you just have to write it once. So in our case, the x minus 1 repeats twice, so you just have to write it once. Okay. Almost done. Oops. This x squared minus 5 is also a perfect square, so this simplifies as x plus 5, x minus 5. And then over here, you're just left with x minus 1. Set that to 0. And then when you actually solve for x, you get 3 answers. You get a negative 5 here, positive 5 here, and then a positive 1 here. And if you forgot how I got those numbers, you could break it into 3 parts. X plus 5 equals 0, x minus 5 equals 0, and then x minus 1 equals 0. And then solve for x. So that's how I got negative 5, 5, and positive 1. Okay. That was 14. Let's do last two problems. The last two problems are pretty simple. I'll show you how. So in exercise 15 through 16, determine whether the function is even, odd, or neither. There is a shortcut to doing this. And I know there's a rule where your teacher probably says if you plug in a negative and your outcome is a positive, it's an even. But I don't want to do that because that takes way too long. There's a simple shortcut way. So to determine if the function is even, you look at the degrees. If all of the degrees are the same, all even, then this function is even. If all of the degrees are odd, then it's odd. Now, if it's an odd and then there's an even degree, then it's neither, because it has to be consistent. So let's look at this one. F of x equals x5 plus 4x minus 7. So this 5 is what? Its 5 is an odd. Now this x, 4x, this has a degree of 1, right? We only care about the degree. So what is 1? An odd. Now the last term, negative 7. Negative 7, if you wanted a degree, it's going to be, you can rewrite that as negative 7x to the 0, right? Because anything to the 0 is 1, and then 1 times negative 7 is negative 7. So that's how you get negative 7. So this degree 0 right here, is that even or odd? 0 is still technically an even. So over here, we have an odd, and even. They're not consistent. They have to be all odds. They have to be all evens. If one of them is odd and even, your only option is neither. Okay? They all have to be the same. Odd, or all evens. Otherwise, it's neither. Now let's look at this one. let's look at the degree. 4 and 2. 4 isn't even, 2 isn't even. So what does that mean? Your function is even. Okay, simple, right? It's so much easier than plugging in a negative and figuring out if the outcome is odd. So this is just way much easier. So yeah, remember, if it's just a regular -7, our degree is going to be 0, and then 0 is an even. Okay, so that wraps it up for this chapter 2 practice exam. So this is what a chapter 2 practice exam for college algebra. So this will help when you take your exams. Okay, so that's it, and thank you.